folks, this is working on physics honors equation with my fellow guest, Harry again, Nicholas Hipolito, and myself, CBills. So for our problems, number 2, it's asking what's the object's time at the time of 0.2 meters. So the object is clearly 0.16 seconds because that is the time at 0.2 meters where the object traveled up at 0.2 meters.
So for number 3, the question asks is how much time it took when the object was at 0.10 meters. And from the line drawn here, we can clearly see that it took 0.05 seconds to reach 0.10 meters.
Okay, so for number 4, we're supposed to find the acceleration. And then we could see how first it has a constant. So we can see how it has a constant velocity, but then here it stops at 0. And then we could put down the given. So basically we have vt at 0, and then acceleration is what we're looking for. The change in x is the position, so 0.2 minus 0 would be 0. It would still be 0.2 meters, and then the change in time it would be 0.16 as the previous graph because that's the max. That's the relative maximum. Yeah, and then so we use the kinematic equation on acceleration. So basically it is change in x equals half multiplied by vf plus v1 times change in time, and we substitute the numbers in. This is what the final answer we get vi, but since every equation has a vi, so we need to take it further. After we solve for the vi, we set it into, we just ignore any number, any one of them, and then find the acceleration. So since we use this one, the first one, so the change in the v velocity of the final equals to vi plus va1, and then we substitute it in. And the final answer, we get acceleration equals to negative 15.625 meters divided by second squared. And since we already found the velocity initial up here, we already know that it's 2.5, so that's exactly what number 5 is asking for. The the velocity, how it started, so it will be 2.5 meters per second, and I think this should be a f, not a t. Sorry.